Students, myself Dr. Madhav Sir, the Associate Professor, Department of Physics, Mahavidyalaya Pimpri. Today we are going to discuss the coordinate system. In coordinates, in this video lectures, the contents of this video lecture. First thing, what is meant by Cartesian coordinates? What are the types of coordinate systems? And we obtained the transformation equation of the Cartesian coordinate systems. In physical problems, we have to deal with several physical quantities like pressure, mass, density, electricity, magnetic field, field intensity, potential, temperature gradient. So these quantities may have different values at different points in a space, and basically to study such point positions to fix. So for this purpose, generally we are using the coordinate system. So in general, the definition of the coordinate systems is nothing but a coordinate system is a system designed to establish positions with respect to given reference point, or a reference system used to fix the position of the point is called the coordinate system. And this coordinate system consists of one more reference point, the style of measurements, linear or angular, from those reference points and the directions or axis in which those measurements will be taken. So simply we say this coordinate system, it's our right hand rule, says x, y and z Cartesian coordinates which are mutually perpendicular to each other. Means at the three different places respectively in the second figure we see that x, y and z is the plane XOY plane, YO Z plane, ZOX plane. These three planes are mutually perpendicular. Means in general the Cartesian coordinates, you remember, means any reference system used to fix the position of point in a space is called the coordinate system. And therefore there are these coordinate systems are classified in three categories. Before that, the use of the coordinate system, where we use generally the coordinate systems. We know that when we learning the coordinates geometry is not just to clear your present class but also helps your understanding in various ways, such as geometry is applicable in computers or cell phones. The text file or PDF file which we open is itself an example of the coordinate planes. In these, the words or images are written in modified with use of the coordinates geometry. Any PDF file which contains text, images and different shapes are placed according to the dimensional coordinates XY systems. All the concepts like distances, slopes and simple trigonometry are also applicable here. So these are the uses of the coordinate systems. The types of the coordinate system. So there are three coordinate systems which are most commonly used. These systems are Cartesian coordinate systems, or is also known as rectangular coordinate system. Second one, spherical polar coordinate system, and third one, cylindrical coordinate system. This Cartesian coordinate system in details one by one we are going to study it, but at this to describe a vector accurately, such as length, angles and projections, etc. So the coordinate systems are generally we use. The first coordinate system, that is rectangular or Cartesian coordinate system. In this Cartesian coordinate system, what is meant by the coordinates, then what is by the coordinate surface, then what is the coordinate lines. So these three basic concepts we must know about the Cartesian coordinate system. So let us see. We draw this Cartesian coordinate system which is the three-dimensional. Basically the point P is a position of this point P in a space. So we using the coordinates x, y, z. So the x-axis, y-axis and z-axis. Any coordinate system which is specified by three mutually perpendicular axes called the rectangular or Cartesian coordinates. In this figure, x, y, z are three mutually perpendicular axes meeting at point O, and this is called the origin. And the values of the coordinates at origin is taken x equal to 0, y equal to 0 and z equal to 0. Consider any point P in a space which coordinates are x, y, z. The line segment OP from its origin to this point P. So this line segment, the value can be written in vectorial form. So direction of this one. The situation, suppose the particle is situated at the point P and its distance from the origin, that is the r. But r bar vector means that is the position vector is this one. Which is the vectorial form is this one. So therefore, the position vector OP can be written as the xi yj plus zk, where I, j, k are three unit vectors, and these three vectors are constant in direction as well as magnitude. We can use r bar a radial distance in this case, and therefore OP bar is equal to r bar xi plus yj plus zk. And what is the magnitude of this one? The magnitude of the position vectors can be determined by the square root of the value of x square plus y square plus z square. So this is the magnitude of the position vector OP is this one. Now let us discuss what is meant by the coordinate surface and what is by the coordinate lines. So to study about the coordinate surface and coordinate lines, let us see the different planes we can show such a as shown in this figure. Let this xz, yz and zz be the coordinates of the point P in Cartesian or rectangular coordinate system, so which is located in this figure. And see what is the coordinates. We know that in Cartesian coordinate system x, y, z are three coordinates is this one. Then what is the coordinate surface? The coordinate surface means x equal to x dash, y equal to y dash and z equal to z dash. What it means? The plane, see in this figure, the plane A, B, C, D is a parallel to YZ plane. Which plane? Is this a YZ plane, and this plane A, B, C, D is parallel to YZ plane. At each point, the value of x coordinates, that is x dash. The value of x coordinates, that is what x equal to x dash. But value of y and z are different at different points. The value of this z and value of this y are different. And this plane contains point P which has x coordinates, and this point P is contains in this plane, and this point equals to value x equal to x dash, and thus x equal to x dash represent the plane surface parallel to yz. So this is the coordinate surface for x equal to x dash. Similarly, we consider the another plane, which another plane h, I, j, k. So this plane is parallel to which plane? ZX plane. This h, I, j, k, this is parallel to ZX plane is this one. So therefore ZX plane means the value of Z, value of what? Y equal to y dash, means let y dash with this y equal to y dash is this. So this plane y equal to y dash, and therefore the equation y equal to y dash represents the plane surface parallel to the yz plane, and that's why this surface y equal to y dash. Similarly, the third plane, that is P, Q, R and S. This P, Q, R, S plane is parallel to what? YX plane. This XY plane or YX plane is this. So these are the parallel, and therefore this parallel plane having the values what? Z equal to Z dash. We say that Z equal to Z dash, means thus Z equal to Z dash represents the plane surface parallel to XY plane. So these are the coordinate surface. Coordinate surface, first one A, B, C, D, which is parallel to ZX. Then second H, I, J, K parallel to ZX plane, and third plane P, Q, R, S is parallel to x plane or xy plane is this one, and that plane is respectively the surfaces and this coordinate surface. Then what is meant by the coordinate lines? The coordinate lines are nothing but they are intersects. See the line LM. So this line LM intersect of plane surface HIJK, and this is the plane HIJK, and this LM is intersect line. Okay, and this at that time what will happen? Y is nothing but y equal to constant. Therefore, this LM is parallel to x-axis. LM is parallel to x-axis. So therefore, LM is parallel to x-axis. So this is the coordinate line LM. The second coordinate line is what? TU. This TU is parallel to which axis? Y-axis. TU is parallel to the y-axis. Okay, and this intersection at this point P is this one. TU is another coordinate lines, and the third one EF. This EF line, dotted lines. This line is parallel to what? Z. Z axis. This is parallel to Z axis, and therefore this line is these lines are known as the coordinate line. So therefore, in Cartesian or rectangular coordinate system, the coordinate lines are respectively LM, which is parallel to x-axis, TU is parallel to y-axis, and EF is parallel to z-axis. So this is the concept of the coordinate surface. What are the coordinates in rectangular system? What is the coordinate surface, and what are the coordinate lines? These 3 points are very important in when we studied any coordinate system. Now the second coordinate system, that is a spherical polar coordinate system. In spherical polar coordinate system, we are using the polar coordinates, and the position of the point is fixed by these 3 coordinates, and these 3 coordinates generally used in spherical polar coordinates. One is r, and second theta, and third one is phi. So see, the coordinates are r. In spherical polar coordinates, the r is the coordinate, theta is coordinate, phi is also coordinate. If this point P is situated in the xyz plane having the coordinates Cartesian xyz, so P can be written the point P r theta phi. R theta phi are the coordinates. So what is the meaning of this coordinates? Now the coordinates are, see, the first coordinate r is this one. So it is a distance of the point P from the origin. So you draw this OP distance is that. OP distance is what? When this particle moving spherically, is that it? Means at that time it forms a radius is this one. Is a radial component. So therefore r is called the radial component. It is the dimension of what? Length. This is the first coordinate spherical. The second coordinate theta, means the angle theta is called the angle between this OP. When we draw this distance OP with the z axis, the angle between the OP and vertical z axis, it is also called as polar angle. This is theta is known as what? The polar angle. It forms a cone is this one. Okay, and the third coordinate, so that is the phi. We know that the point when we situated, means whatever the distance we measure from the origin, that is called the r coordinates. And if the particle P moves from clockwise anti-clockwise direction, he rotates from P to suppose z axis, whatever the angle he made, that is called the polar angle theta. And if the point P, you draw the projection of this OP on XOY plane, means you fit a perpendicular to the XOY plane and meet at point Q, and then the distance of this point Q to O makes with respect to x axis, that angle is known as azimuthal angle and is denoted by letter phi. So phi is known as, is called the azimuthal angle. It is the angle between the x axis and OQ, where OQ is what? OQ is the projection of OP on XY plane. This angle Q is nothing but XOQ. Theta means what? Angle POZ or ZOP, that is angle theta is this one. So these are the 3 coordinates in spherical polar coordinate: Cartesian XYZ, spherical r theta phi. Now then, what are the coordinate surface? The coordinate surface in spherical polar coordinates, first thing, r is constant. R is what? Constant means this OP distance is nothing but is constant everywhere. Means the point P is situated on this circle anywhere, So this distance is always constant, means r equal to constant. Means r equal to constant represents a surface of sphere with its center as origin and OP as a radius. So this is the first surface, and that surface is what? R equal to constant. The second surface is theta equal to constant, means polar angle theta is constant. What it represents? It represents the curved surface of a cone. See, this P situated means theta is constant, and this theta will be represents the curved surface of cone with its vertex at origin. Origin. So this is the second coordinate surface, a spherical polar system. Then the third coordinate system, third surface is what? Phi equal to constant. So phi equal to constant means this azimuthal angle phi. What he represents? He represents the surface of the half plane with its 1 inch along the z axis. So these are nothing but the coordinate surface in spherical polar coordinates. Means we know that what is the coordinate system and what we mean by the coordinate surface. Similarly, we can say that the coordinate curves are basically the lines. So there are three coordinate curves respectively r, theta and phi. This one represents the three coordinate curves. Means line OP is called as r curve, theta curve and phi curve respectively, the line. So then one of the important things to study about the transformation equation means how we converts the value x in terms of this r theta phi, or y in terms of r theta phi, or z in terms of r theta phi. I mean that is this Cartesian coordinate in terms of spherical coordinate system, or in spherical coordinate system in terms of Cartesian coordinate system. So let us be studying the transformation equation is the spherical polar coordinate system. In spherical polar coordinate system, let us we can see in this figure, consider point P x, y, z, and its spherical coordinates are r, theta, phi, and the distance from the origin we said that is the r bar is this one. Then we draw a theta perpendicular from point P on the x, o, y plane and meet at point Q. Also from this Q draw perpendicular on the y axis, meet at point M. Again we draw perpendicular Qn on x axis, Qn perpendicular to x axis. Then the coordinate x, y, z in Cartesian coordinate system means the distance along this x axis, that is x, means that is ON is nothing but x, or OM is nothing but y, and this OZ is nothing but z. Means let me see x equal to, what is the value of x in terms of this? X equal to ON, or that is value of MQ. Means ON is parallel to this one. We completed here parallelogram. Okay, so that is the MQ. X equal to ON or MQ. Similarly, what is the value of y? Y is nothing but is OM, and OM is nothing parallel to this NQ. So therefore means y equal to OM or NQ. And then what is the value of z? Z is nothing but is a PQ. So PQ is nothing but the parallel to the z axis, means that distance is nothing but z. Similarly, the coordinates r, theta, phi of a point P in spherical polar coordinate system are r equal to, what is the value of r? R equal to what? OP. Then theta equal to what? Theta is POZ or ZOP, and phi is nothing but what? That is NOQ is this one. It's r equal to OP, theta equal to ZOP, and phi equal to NOQ is this one. Okay, so we consider this figure, then to study about the value of this x, value of z, means that is the transformation equations. The first we studied about the transformation equation from Cartesian coordinate system in terms of the spherical coordinate system. So in this figure, by using a simple geometry to find out the value of this x, y or z is this one. So let us see in figure. We know that x equal to what? X equal to ON. But this ON is nothing but what? ON is parallel to what? MQ is this one. Okay. So how to find the value of this ON? means ON by using this right angle triangle ONQ. So ONQ is nothing but what? So this angle is phi. So therefore we use a trigonometry Pythagoras. So what trigonometry? Cos phi. Cos phi is equal to ON. Cos phi equal to ON divided by OQ. This is hypotenuse. Okay. Means adjacent side divided by the hypotenuse. Means cos phi is equal to OQ. You see, x can be written that is x equal to ON, but ON is nothing but that is the OQ. Cos phi is this one. Okay. But from this geometry, so what is the OQ? So this OQ, you have to find out. You see, this angle OQ is this one, is theta. Okay. So this is the adjacent angle. This value is also what? Theta. This one, opposite angles. Opposite angles. So this value is theta, and this is we have drawn the theta perpendicular PQ on the x or y plane. So therefore, this value to find out here means x equal to OQ. So what is the value of OQ? This is the right angle triangle, and this OQ is nothing but what? Here we consider this theta, and this theta equal to r sine, means sine theta. So therefore, the value of OQ is nothing but what? R sine theta. And this value of r sine theta we put here, OQ equal to, therefore x becomes what? R sine theta into cos phi. This is the first transformation equation. What is transform equation? First, x equal to r sine theta cos phi. Similarly, what about this y? Y is nothing but is OM. But OM is parallel to what? NQ. Is y equal to OM. And this OM is nothing but what? Again that is OQ cos phi. Just similarly, y in this case, that will get OQ sin phi. But OQ is nothing but that is r sin theta. We put the values and we get y equal to r sin theta sin phi. So this is the transform equation. And the third equation is what? Third equation, that is z. And z is nothing but that is PQ. PQ equal to what? Z. But this geometry, by using this trigonometry, so this angle is theta. Okay, so then what is my, how to determine the PQ? This is the right angle triangle, this is value of R, this is value of Z, isn't it? The right angle triangle. So hypotenuse what? Adjacent side Z divided by the hypotenuse PQ, but that is what? R. So therefore Z equal to what? Z equal to PQ. Z equal to what? PQ, and that PQ is nothing but that is OP cos theta, and therefore OP is equal to R, and therefore Z equal to R cos theta. So this is the third transformation equation. Means here these Cartesian coordinates in terms of spherical coordinates are respectively x equal to r sin theta cos phi, y equal to r sin theta sin phi, and z equal to r cos theta. These three equations are known as the transform equation. Now another way we have obtained this transform equation means that is from spherical coordinates in terms of Cartesian coordinates. So these three equations important, means that is first, second and third. Then squaring this equation, first equation, second equation and third equation, taking the square and add these equations. The squaring is what? X equal to r sin theta cos phi. Take the square, x square. May x square is nothing but what? R square sin square theta cos square phi. Okay. Similarly, y square is what? Y square is r square sin square theta sin square phi. See, so this is the first value. X is x equal to what? R sin theta cos phi. Okay. Y equal to what? R sin theta sin phi, and z equal to what? R cos theta. Which happens, square of this one will get all this squaring value. And after the simplification, so we take the r square common. Here sin square theta, r square sin square theta common, cos square phi plus sin square phi, and plus r square sin theta. But we know that cos square phi plus sin square phi is 1, and therefore r square sin square theta plus r cos square theta, and then r square you take common, the remaining is what? Sin square theta plus cos square theta, and therefore sin square theta cos plus cos square theta is 1, and final value we get r square, means root x square plus y square plus z square is equal to r square. Therefore r equal to root x square plus y square plus z square, and the value of this r is always greater than equal to 0. It's not negative value. This r is always positive, this one. So this is the first transform equation in terms of what? Cartesian coordinates. This r can be written x square plus y square plus z square. Similarly, so we can determine the another transform equation with help of we know that z equal to r cos theta. So therefore cos theta equal to z upon r, and we know that value of the r is root x square plus y square. We put these values and simplify it. So we get the theta, that is con inverse z upon r, or cos inverse z divided by root x square plus y square plus z square, and this theta, basically polar angle, it changes from 0 to pi, 180 degree. If pi is greater than equal to pi, greater than equal to 0. So this is the second transform equation in terms of Cartesian coordinates. And the last transform equation, that is with taking the ratio of these two equations, y upon x, and putting r sin theta cos sin phi and r sin theta cos phi. Therefore tan phi is this one, and phi equal to tan inverse y upon x, and this tan inverse minus y upon x, phi angle, the variation from 2 pi is greater than equal to 0 is this one. It changes from 0 to 2 pi. So this is the another third transform equation. Okay. So these transform equations for spherical coordinates to Cartesian coordinates, isn't it? R equal to root x square plus y square plus z square, and second equation is theta equal to cos inverse z upon or z upon root x square plus y square plus z square, and phi is equal to tan inverse y upon x. So these are the Cartesian coordinates in terms of with help of the spherical polar coordinate transform equations. Now then we study about the third coordinate system, that is the cylindrical coordinate system. In cylindrical coordinate systems, when there are three coordinates we use, one is rho, phi and z. In Cartesian coordinates, the x, y, z are coordinates, and rho, phi, z are the coordinate cylindrical systems. So the coordinate rho is constant, it is ways p is x, y, z, the points are the Cartesian coordinate, rho, phi, z as a coordinates in cylindrical polar coordinate system. From this figure, the value of coordinates are the coordinates rho. The first coordinate is rho. So what means the rho? Rho is the distance from the point P to the O dash. This means O dash P is equal to rho. Okay. Rho equal to O dash P. The coordinates rho. The second coordinates phi, that is azimuthal angle, and this azimuthal angle is again XO phi, which is the projection of this O dash P is this one. Okay. The projection of the point P on the XO plane, and that's why he get XO Q is this one angle. The coordinate Z, the third coordinate, that is Z, and it's a distance along the Z axis, means that is PQ is nothing but what? Means PQ equal to Z. Then what are the coordinate surface? In cylindrical coordinate system, the surfaces respectively, the rho is constant, and this rho equal to S1, the first S1 surface, and this S1 surface represents the surface of the cylinder with its axis along the Z axis. Then second coordinate surface, that is S2. So S2 is the half plane with its one edge along the Z axis, means phi equal to S2 is the half plane with its own edge along the Z axis. And third one, Z equal to S3. Z equal to S3, this is the third surface, and it represents the plane surface perpendicular to Z axis at a distance equal to S3 from XY plane. So then the three coordinates curve respectively the intersection of the surface phi equal to S2 and Z equal to S3 is a straight line O dash P called as the rho curve. The intersection of the surface z equal to s3 and rho equal to s1 is the circumference of the circle of radius o dash p, and the circumference is called phi curve, and the intersection of the surface rho equal to s1 and phi equal to s2 is a straight line, and pq it is called the thread curve. So these are the coordinates curve in cylindrical coordinate system. Then how to